In various occasions like stock market or trading market or anywhere, you might have came across words like an increasing function, an increasing graph or decreasing graph, or a constant or sideways graphs. But do we know actually how can we depict an increasing or a decreasing function? Well, with an easiest example, I am going to show you how can we find out if the function is either decreasing or it is increasing. So if we look in this graph, you can look from left to right, the height of the function is changing, right? But what exactly is happening to the height of the graph? Well, it has to either decrease, it has to either stay on the same line, or either it has to increase. So if you look from left to right, can you tell specifically whether it is decreasing or increasing, and this function is either increasing or decreasing? Well, the answer is very simple, okay? And now we'll see how this happens. So if you go from the left point, which is from minus infinity till 0, you can find that the graph is constantly losing its height. So we can say that the graph is decreasing towards 0. So from left side till 0, you have the graph as decreasing. Now if you look at the exact 0 point, after that we can say that, well, the graph is going upwards. So if you see that graph is going upwards, we can say that the height is increasing. So in this manner we can say that the from 0 to right side the graph is increasing. But this is just visual representation, right? And we know that y is equals to x square. We have it in terms of easiest manner. But what if there is a complex function like x raised to 5 or x raised to 7, x cubed, and we don't have a specific graph? So in such cases, how do we know if the function is either increasing or decreasing, or it is staying constant throughout, just like a straight line? Well, we have to see it, and for that purpose, since this is an applications of derivative, it is easy to tell you that since we have derivatives with us, we can use that tool to understand what is the slope of the height. So slope is nothing but a tangent, and you can depict some kind of inference from having a tangent at a specific point. So if we look in this graph, we can see that there are two tangents, okay? One is to the right of 0, one is to the left of 0. Now we have understood that on the left of 0 there is a pink tangent at a point, and that side is a decreasing, right? And on the right side there is a green tangent which is increasing. Now why is it increasing or why is it positive? We'll see what happens. So if we look at the green tangent, you will see that when you go out and find out what is the tan theta of that tangent, it is necessarily going to be a positive number. Why? Since the cos is positive, since we have sine as positive and cos as positive in the first quadrant, we can easily say that this particular green line or the tangent on the right side is going to have tan theta, or the derivative of that particular graph on the right side as positive. But on the left side, if you see, the pink tangent is going to have the slope as negative. So we can say that when we have a positive derivative of that particular function, if that is greater than 0, which means positive, then we can say that it is an increasing function. And in case of having a negative slope or a negative derivative which is less than 0, then we are going to have a decreasing function. Now what if the derivative is 0? So you can say that it is a straight line. Since we don't have a rise, we cannot have any sine theta, and it will be immediately 0 upon 1. So if your f dash is 0, then it's a straight line and it's a constant function. Now we'll go through few examples in order to understand how the different functions. So we need to further simplify this equation, and we'll just open the brackets inside. So we have f of x as x square minus 2x raised to 2, and this will be easy just because we can derivate it easily and fast. So f dash of x is going to be 2 times x square minus 2x times, now we have to derivate the inside function, which is x square derivative is 2x minus 2x derivative is going to be 2. So if we take out 2 common from the last term, we get 4 over here, and the first term we can again write it as it is, which is x times x minus 2. And since we have taken 2 out common and we have multiplied here, since we have got 4 here, we can say that the remaining function is x minus 1, and this is your last function. So this is the most simplified way, and here you have to find out what are the values of x. So x values we can insert directly, but for an increasing function we know that f dash of x should necessarily be greater than 0. So we have to find out the values of x such that f dash of x is greater than 0, right? And here we have 3 terms. So how can we exactly go through this f dash of x having these 3 terms to be net positive? Well, we can say that if we check the first term, which is nothing but x, and if we put x as 0, then the whole term is going to be 0, right? So now from here we got a first confirmation that x necessarily needs to be greater than 0, right? Now let's again take a value which is greater than 0. Let's take 1. So now you can see that if we put 1 over here, this again f dash of x is going to be 0. Since that term is going to be 0, anything multiplied by 0 is going to be 0. So again we have a conclusion that x also needs to be greater than 1. And in the same way, now you must have known that f dash of x, if we put x as 2, then again it is going to be 0. So it needs to be, needs to be greater than 0. So if we combine all these terms and all the equations, we can say that x should belong to anything which is greater than 0. So 2 is not included, so it will come round brackets 2 till the positive infinity, and this is your answer. So for any values from 2 up until infinity, the function is going to have the derivative as greater than 0, and thus showing that the function is an increasing function. Now we'll look after the second question. Now the second question is very interesting, right? And we need to find out where are the intervals where we can find the function is increasing and where are the intervals where the function is decreasing. So first we'll write down our necessary steps, which are f dash of x, if greater than 0, then this function is increasing, and f dash of x is less than 0, then this function is decreasing, right? And we can find out what is f dash of x immediately in one step. So it is going to be 6x square minus 6x minus 36 plus 0. Now again we can take out 6 common, so we have x square minus x minus 6, and also we can again just ease out what are the factors of this. So it is going to be x square, so the product is 6 and the sum is minus 1, so you can say this is minus 3x plus 2x minus 6, and if we factorize this, what we do, we get, so in the first we have x common, and in the second we have 2, so we have x plus 2 times x minus 3, isn't it? So now we'll see what are the values and what are the intervals where we are going to find out the actual sum where the increasing function and decreasing function can be taken out. So in this example, if you look carefully, if you put x equals to minus 2, this term is going to be 0, right? So at that particular point, the graph has to be exactly at straight line point, which is x equals to 0. Also, when the value x is equals to 3, it is going to give us this term as 0, isn't it? So we can say that if the value is greater than 3, in this case, this term is going to be positive, which is the first term. Let's call it this term as first term, and in this case this term 2 is also going to be positive. So in the case of x is greater than 3, the graph has to necessarily be positive. So when f dash of x is greater than 0, it is going to be an increasing function for value what? X is greater than 3. So x will belong to 3 till infinity for increasing functions. So these are the intervals, right? Now let's take the reverse thing of it, okay? And now we'll check what happens over here. What if we take any value which is less than -2, right? What if we take values such as x equals to -3, and if we take, you will see an interpretation over here that if this value goes on less than -2, which is -3 or -4, this term is going to be negative, isn't it? The first term. And in the second term, since it's a negative value, the second term is also going to be negative, isn't it? Which means that in this particular case where x is strictly less than -2, in that case also the whole term, which is f dash of x, is going to be greater than 0, since two negatives will make the whole term as positive. And in this case also, when x belongs to -infinity till -2, your function is going to increase, isn't it? And anything in between, so what is in between? So let's have a straight line drawn over here and we'll understand what exactly I'm going to tell you over here. So if we take so I have a line over here, right? And let's say if -2 is here and 3 is here. So what are the numbers in between -2 and 3? We can take -1, we can take 0, we can take +1, right? And in all these cases, if you check what is f dash of x, you will immediately get the answer as all the terms are going to give you only one solution, which is f dash of x is going to be less than 0. And by such methods we can say that since it is negative, it is a decreasing function, and x will belong to strictly, since there are -2 is included in it, we have square brackets -2 till +3, and here both the numbers are included. But so the decreasing function is going to be f dash of x, since it is less than 0. So decreasing functions values or the intervals are going to be x will belong to -2 till 3, and make sure that the brackets are rounded, because -2 and 3 cannot be included, since they'll zero out or they are just 0, and they will make the function as constant at those particular points. Now we'll take another simple example which is not as hard as this, and we'll try to get on the answers very easily. Now so this is another question which is very easy, and we'll try to do it within 10 seconds, okay? So dy upon dx, or rather if we take f dash of x, if it is greater than 0, it is going to be an increasing function. If it is f dash of x is less than 0, it is going to be an decreasing function. So immediately what we have, f dash of x is going to be 4x minus 3, and in such cases we just need to find out what is the 0. So if we equate f dash of x to 0, we'll immediately have a straight line. So if we equate it to 4x minus 3, we have x equals to 3 upon 4. So anything which is greater than 3 upon 4 will give you an increasing function, right? And anything which is less than 3 upon 4 is going to give you what? Decreasing function, isn't it? So we have our intervals. So x will belong to 3 upon 4 till positive infinity, and this function is going to be increasing. And in case of decreasing, x will belong to minus infinity till 3 upon 4. right? And in case of x is equals to 3 upon 4, it is going to be a constant function. Now we have came across different examples, like 3 examples, and this is the knowledge which we have got from finding the nature of the functions. So now you have understood two major things. First is the nature of functions, which is what we have learned today, either increasing, decreasing, or a constant. Also, in the previous video, which you can click over here, we have seen how to find out the tangents and the normals to any curve, right? And what if we combine all this knowledge of having tangents and having increasing and decreasing functions, and if we apply it, what is the outcome or what is the derived information about graphs which we can actually get? Well, in the next video we are going to go through a very interesting and a very important concept for JEE and 12th standard students, which is maxima or minima. So what is maxima and minima, which is for the next video. I'll just give you a preface. So maxima is nothing but the highest point of a function. So you can use your brains over here, start rumbling a bit, where you can find that having a maxima is like the highest peak point of that function, and here you can use your slopes and derivatives to find out. Just in another case, in order to find out what is the minima or the lowest point, you will also need to have the thorough knowledge of derivatives. So in the next video, we'll see what is maxima and minima. Thanks for watching.